10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program. Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading. Although the surface appears to be very, very fine-grained as you get close to it, it's almost like a powder. Ground mass is very fine. I'm going to step off the limb. That's one small step for man, one giant leap for mankind.
That's one small step for man,
Pequeño paso para
one giant
un
leap
gran salto
for
gigante
mankind.
para la humanidad.
Welcome back guys to another video, and in this video I am going to show you guys pretty awesome stuff. So Dave Spice just tweeted a few moments ago that he was able to get the Apollo guidance computer. So the computer that was on board the Apollo mission and was there to guide the Apollo spacecraft onto orbit and in general guide it through its journey. And he was able to get it to emulate on the Raspberry Pi. Pretty awesome stuff. So I followed his link and was able to do the same. So I'm just here to show you guys how this all works and what this is. Now it's pretty simple, straightforward to compile it on your own. I leave the link in the description for the main project space, and it's pretty easy to navigate and download the source code and then compile it for yourself. So what we'll do is open up for the Apollo 11 command module. Now why specifically Apollo 11 is because it was a very significant flight for mankind, a very significant mission, and that it was the first one to land man on the moon. Now there are controversies, but we are not going too deep into it. So let's fire that up. Let's run that, and this is what we get. So right here we have a bit of data that is coming out as output from the command from the Apollo guidance computer, and this is our main computer. Now back in the day it doesn't used to look like this. This was a hardware device, this was a physical device, these were the physical buttons. This was a physical display area, probably mostly made up of the 8 segments or the 7 segments FND kind of display, and the lights and whatever text you're seeing here were physical bulbs. Now I doubt they had LEDs back then. They might as well have been neon or normal tungsten bulbs. So this was what it looks like. I'll also link in a photo right here what the hardware actually looked like. So these actually used to be very application specific devices, somewhat like application specific processors that we have right now, but they were hardware devices. They couldn't do much more than what they were physically designed to do. So this module was just designed to guide the mission and the Apollo mission in general, and it was used for a very specific task. Most of it was written in assembly and executed in very code kind of language. Now by code I mean really actual coded language, so that others cannot intercept what was being said. So as you can see, we have odd buttons like verb and noun. Now in this situation nothing really makes sense what verb and noun means. They are actually just the part of that coded language. So I'll just open up the project web page so you guys can see, and they actually have pretty awesome guides and some codes that we can actually work with. So yes, so in their whole guide kind of thing, I'll be executing a few of them. They actually are replacing verb with V and noun with N. So for example, the first one is the view the alarm codes. So what are the alarm codes? You can easily view them, and for that what we have to do is type in. Now we have to punch in. So here it says we can key in V05, N09 and E. E is for enter. So verb 05. So as you can see, right below the verb we have the digits 0 and 5, and then noun 0 and 9. So between under the noun we have 0 and 9, and then press enter. So these are the alarm codes, and yes, that's pretty much it. I don't really know what the alarm codes mean. They can actually be codes to enable or disable some sort of alarm or some stuff like that. So let's go ahead and DSKY lamp test. So yes, this will probably enable some lamps on our module right here, and then also kind of test all the segments of the display to check if they are properly functional or not. So for that what we need to do is verb and 3 5 and then enter. So this ran through a kind of lamp test, so and that turned off quickly. So you could see that all of these lamps were lit, and then all of the segments are also lit. So we can do that again. So verb and 3 5 enter. Again all of the lamps are lit, and then so is the display. So yes, you need to remember that this is a physical device, and there was no computer, a general purpose computer on board back in the day that would display such a user interface. It was all general purpose. So current time, what current time is set on to the clock, it can be done via keying in. You have two options for that. I'll go with the second one. So V16 and then noun 6 5 and then enter. So this is the current clock. So we have 5 hours and 56 minutes and 19 seconds and counting. So you can also see each time there is some computer activity going on. Each time it's calculating something. We do have a flashing comp activity over here. So for almost every second we do have a comp activity flash. It turned back off a few seconds ago, but it's flashing again. So this is what there is. So examine contents of the core row. So again, as I said, this was a very bare bones system. Data were all set into different registers. So core rope is apparently R3, or as I understand, register 3. So we can actually key in V27 and then noun 0 2 and then enter, and this will show us the value of register R3, I guess. So this should be it. I'm not extremely sure that this is what the apparent output should be. So fresh start is to reset everything. We have verb 36E. So this command would apparently clear everything out. Pretty awesome stuff. And then the source code actually provides a lot of functions that can be manipulated and you guys can experiment with that. So I'll just show you guys where that is, and should be this one. So as you can see, I don't know how clearly it is visible, but these are all the different codes. So we have the verb lists and values that would do stuff. And so let's try V27E. Now most of them can't just be used directly, and as you can see, something like this would give me operation or operation error. So this means what I put in is wrong apparently. So yes, this was as less I can understand, and I don't really have much knowledge about it, but this was emulating the Apollo guidance computer on the Raspberry Pi. Pretty awesome stuff to play around with if you are into space travel and space missions and all of that stuff. You can actually play with it. Great opportunity. So you do have for Apollo 9, 11, 13, 15, 17. So these were actually pretty similar, and the commands that I had just tested were work almost identical across the board, so there would be minute differences. So again, thank you so much guys for watching, and I will see you in the next one. Don't forget to like, share and subscribe, and once again thank you so much for watching.